Hi, this is Thsinde778 coming at you, and today on the channel I've got another multimeter to present. So what I have today is a Thsinde 18Z3 multimeter. So let's go ahead and get right into the unboxing. So as you can see, it comes in a plain Jane box, just like the 1152T came in, pretty nondescript. Let's just go ahead and get her open. Let's see what we get. Alright, first we get a manual. And I'm going to show you some specs here. Here's some specs for you. Okay. And then the next couple of pages. Hopefully that's focusing. And even some more specs. Like I said, this is a good one. It's got a lot of stuff. There we go. Alright, I think that's it for this. Yep. Alright, so you get the manual. We'll move the box back over here so we can start piling this stuff up here. So the manual, you get a set of, let's see, 1, 2, 5, looks like 5 alligator clips. Okay. Set of leads, a set of pincher leads, okay, you get a case that's a little bit smashed up, but yeah, get a case, and we get some more accessories in here. We're not done with that yet. Get a set of alligator clip adapters, a battery, a set of thermoprobes, and yet another set of leads. So you get 3 sets of leads with this thing. And last but not least, after all that, we get the multimeter. So here she is in all her glory, the Thsinde 18Z3. Okay, and here we go with the overview of the Thsinde 18Z3. First thing I'm going to do is bring out a sibling just to give you a size comparison between the 1152 and this one. Here is the Thsinde 1152, and as you can see, they are virtually identical in size and also layout. There is virtually no difference. This one has a couple more functions, but otherwise they are pretty much the same. This one does have a reverse EBTN display. This one, of course, is just a standard LCD backlit display. But just wanted to show you the comparison. So I guess you could call this one another Fluke clone, but I don't know that I would necessarily call it that because I don't really think it tries to mimic any Fluke, at least not that I know of. So let's go ahead and turn this on. I'm going to show you the backlight here. This is a 20,000 count multimeter and has dual display. This is actually the secondary display is also 20,000 counts, I do believe. So let's go ahead and go through the buttons here. The backlight, unfortunately, as you see, does not stay on very long, about 15 seconds. So we're just going to leave it like so. Get your select button, for the functions, hold and backlight controls, manual ranging button, rel button, hertz and duty cycle, peak, I believe that's max and min, it may just be max. As far as the the options in the rotary selector go, we've got AC voltage with hertz, DC voltage, AC and DC millivoltage with the thermoprobe. Not sure if it measures hertz in this mode. Going by that silk screening there, it looks like it maybe doesn't. Okay. Next up is your diodes, continuity, resistors and capacitance, hertz and duty cycle, AC and DC amps, AC and DC milliamps, AC and DC microamps, and finally NCV. Alright, so down below here, I'll go ahead and turn that on again just so you can see it. Oh yeah, kind of sensitive, or I'm conductive tonight, one or the other. Going from left to right here, we've got our 10 amp current input jack, 10 seconds maximum. It is fused. Then you have your microamps and milliamp jack, fused for 200 milliamps. And we've got our common jack, and then of course the jack that does the voltage, resistance, hertz, continuity, capacitance, temperature, etc., etc., etc. This is being touted as a category 4 600 volts. I can most definitely tell you this is not a category 4. Okay, and with that, I'm going to go ahead, let's turn it off and let's get into the battery compartment. So let's go ahead and do that real quick. This is very similar. Let me get my screwdriver out here. Very similar to the 1152T as well. All right, let's get this opened up here, and comes off. And as you can see, it takes I already got a battery in here. And then of course we got to take the condom off. It does have a brass insert, as you can see. Let me hold that up there. Yep, see right there. Let's go ahead and take the battery out. I'm going to go ahead and break this down. See how hard it is or easy it is to get this condom off. I'm not really sure. Haven't tried this one, and it's been a while since I've been inside the 1152T, so we're just going to wing it. Okay, we got it now. So off with the condom. Okay, we can jump off then, that's fine. On the back here we've got 4 screws in each corner, as you can see, here, 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 and here. So let's go ahead and get these taken out. All right. Comes apart very, very easily. Okay, and let's go ahead and I'll get this set up for a close-up. We can do the take a look at the PCB. Okay, and here we go with the PCB close-up. So we're going to go from right to left here, I guess. We have the split variety type jacks here. Kind of a smallish current shunt. Pretty good size fuses in this thing. This is a 200 milliamp rated at 250 volts, and the other one is 10 amps, and I am not seeing a rating on it. Let's see if we can actually, no, it's not going to move. Let me take a quick look under there. I would guess it's probably rated for the same. This does look like an HRC fuse though. So I would call this a category 2, 250 volt. Okay, this was the manufacturer date on this. Looks like the 40th week of 2020, and the revision on this board looks like from March 28th, 2019, VC 282, version 0.9. Here are your battery contacts right here. We've got a couple of resistors in series here. Looks like a couple of diodes right here, and then 2 pairs of resistors in series right here. We have a single PTC right here. It looks like some more resistors right here. Looks like we got 2 separate controllers. We've got that's the main processor right here since it's blobbed out, and this probably controls the LCD. Crystal for each, a couple of caps here, the speaker here. The NCV, I am assuming, is up here somewhere on the top. It's probably on the other side, I guess. Also have 2 sets of ports for, I guess, configuration right here, and then another set right here for configuration and calibration, I would guess. And that's basically it. Pretty simple board. I do like the size of those fuses. It's a little bit disappointing it only had one PTC, but it is what it is. All right, let's put her back together and let's do some tests. Okay, here we go with the DMMCheckPlus tests. Just to give you a quick view, a close-up of the more close-up of the how that backlight looks there. Looks pretty good. I don't think the camera does it justice, but looks very nice and sharp in person. It's a real shame that it does not do more than 15 seconds on that backlight. Okay, here's the AC or DC 5 volts. This should be 5 volts even, and it's reading it as 4.998. Okay, let's switch over to AC. And on AC, we're getting 4.969, 4.970 looks like. Yeah. Reading a frequency of 100.00 hertz. Let's see what we get on the duty cycle. And it is reading it as 50.0. Let's see if we can do any better by just switching it over to the actual frequency. Yep, 100 hertz, 100.00 hertz. Yeah, duty cycle's the same. All right, so no problem there. Did it to the best of its ability. All right, let's go ahead and move over to the resistors. First up is going to be the 99.99 ohm. And it is reading it as 99.96, 95. Looks pretty good there. Wavering just a little bit, but that's all right. Okay, next up is the 1.0005 kilo ohm. And we are getting it as 1.0004, really close, 0.03. I'll take that. All right, next up is the 10.0044 kilo ohm. And it is reading it as 10.002. Not bad. All right. Next up is the 100.064 kilo ohm. And we are getting it as 100.0302 looks like. Again, very, very close. Did pretty good on that. All right, let's go to the caps. Okay, first up is going to be the 992 picofarad. And we are getting 983 picofarads. Didn't look like we needed to rel anything out, so we're just going to keep going. All right, here is the 10.07 nanofarad. And it is reading it as 10.049050. Really, really close. Pretty good there. All right. Here is the 100.6 nanofarad. And we are getting 100.47 nanofarads. Again, very, very close. Nice, nice, nice. Okay. And here we go with the hard one. I believe this was recorded at a 10 kilohertz frequency. I got a feeling this one probably reads at 100 kilohertz, so we'll see. Yep. We are getting, should be 1.007, and we are getting 1.03, 1.0299, that in that range. Yeah, so, okay. But all in all, looks pretty good. Oh, got to do one more thing here. We got to check the current. So let me get this repatched real quick. Okay, we're going to go into the, we'll start off in the milliamp range like we normally do. This should be 0.9996 milliamps on DC. Let me get it in DC. And it is reading it as 0.989 milliamps. Let's go to the microamp range. Let's see what we get there. 997 even. Pretty close. Pretty close. All right. Let's try the AC. Let's switch over to AC milliamps. Actually, we're just going to keep it in microamps. Okay, we are getting a frequency, and again 100.00 hertz, and it is reading it as 991 microamps. This should be 1.001 milliamps, or basically 1001 microamps. Let's put it in the milliamp range, see what we get there. Yeah, it's actually better in the microamp range. But all in all, I would say did pretty well on this test. All right, so we're going to do the first set, which appear to be the more inferior ones. I think the other leads are actually better. Yep, these are very, very thick, rigid plastic. No covers on them. No covers at all. In fact, look at that. That's not good. Kind of got smushed a little bit. Okay. Hopefully they'll still go in. Looks like they did. Okay. So no covers on these. I guess that's the price you pay for getting so many accessories. Yeah, the red is just like that too. Yeah, I can tell you right now I'm probably not going to like these leads, but we'll give it a shot. Okay, let me get that into continuity. There we go. Let's see what we got here. Wow, they're actually not that bad. Yeah, there's some oily crap on there, so I'm losing. Yeah, the resistance is kind of all over the place, but yeah, those actually aren't as bad as I thought they would be. They're usable. All right, let's go to the second set of leads. Let's see what we get with those. Get those out of the way. So just. All right, the second set of leads I'm hoping is like the 1152T, where we actually get. Let's see if we do. These actually do have covers on them. Let's see what we get here. Oh yeah. That's what I'm talking about. Gold tip leads, just like the 1152T. So these should actually be pretty decent if they are the same. I'm assuming they're the same kind of leads, but only one way to find out, I guess. They're also a little bit deformed there, although not quite as bad as the other ones. Okay, so let's go ahead and give these a shot. As soon as I get them untwisted here. All right. Oh yeah, much more consistent. Going down to about 0.35 ohms. Much better. Yeah, definitely use these leads. No question. These are definitely superior to the other set. Okay. All right, so let's go ahead and do the probe masters. I think the only real difference we're going to see is the probe masters probably will, let's get these up here, probably will have a little bit better continuity, or I'm sorry, a little bit better resistance, or should be completely zero, but let's find out. As soon as I get these taken off there. I'm glad I'm done with that. Those are very good leads. Those are definitely comparable to the Probe Masters. I would say they're not quite as good, but they come pretty close. I'd use them, definitely. All right, let's go ahead and try these. See what we get with these. Yeah, going down to 0.3 ohms, okay. Yeah, they're just fine. Yep, slightly better, but like I said, those stock leads with the gold tips, I would definitely use those over the other ones. Okay, here we go with the Fnirsi SG-003A. We're going to do the current test here. We're going to start with 4 milliamps and reading it a little bit low, 3.978. All right, let's go to 7 milliamps. Okay, again low, 6.961. All right, let's go to 10. And again a little bit low, 9.950. Not real low though. This is not that far off. Okay, 15. Okay, again reading it a little bit low. All right. Okay, 14.924. And finally 20. This should be more like 20.03, and it's reading it, yeah. Reads current just slightly low, but still it's not off by that much. Okay, here we go with the AD584M DC voltage test. I've got everything set up here. Got my reference meter ready to go. And let's see, we're in right mode here, All right, let's go ahead and give this a shot. We're going to start off with 2.5 volts. So let's patch them in and see what happens. Okay, reading 2.5007 as always on the UNI-T, and we've got 2.499 on the Thsinde. Not bad. Okay, here's 5 volts. Okay, 5.0055 as always on the UNI-T, and the Thsinde is reading it as 5.003. Again, not bad. All right, let's go to 7.5. Okay, 7.502 as always on the UNI-T, and we've got about 7.501. Yep, 7.501 I would call it on the 18Z3. Again, pretty good. All right, here's 10 volts. You get got the 10007 wavering a little bit tonight because it is a little bit cooler, and 10.004 on the Thsinde, wavering up to 5 and down to 3. Again, very, very good. All right, no problems there. All right, let's go ahead and switch this over to the power supply so we can do the 32 volt test. Okay, let's see what we get here. And we are getting 32.001 on the UNI-T and 3199, 32.00 on the 18Z3. Again, very, very good. Okay, let's go ahead and start off with the diodes. We're going to start with the LEDs. So let's go ahead and get to it. So we get red with a reading, okay? Yellow with a reading, all right, good. Green, no reading, lights it up well though, okay. Blue, lights it up, no reading. This is based on 2, this is why it's not reading those drop voltages. White, yep, no reading. And just to do the RGB, here's red, green, and blue, all right. Okay, a little bit disappointing, but I was kind of expecting to see that. All right, let's go ahead and do the regular diodes. So here is the rectifier. .562120, okay, good. Here is the fast recovery. .5224, looks pretty good, okay. Next up is the Schottky. .2049, again, right in the range, should be really good. Okay, switching. .6211, looks pretty good. All right, last but not least, the germanium. There we go, .2884, looks good. All right, so yeah, no problem on the diodes whatsoever. Okay, here we go with the resistance readings off the substitution box. As you can see, we got some residual reading in there as we normally do, so let's go ahead and roll that out. Okay, here's 1 ohm. Okay, .99, looks good. 10, right on the money. 100 ohm, pretty good. 1K. Got to take the rel off now. Yeah, it looks pretty good there. 10K. Yep, we're pretty good there. 100. Oh yeah, looks good. 1 meg. I'd say pretty good, just about right on the nose there. 2 meg. Yep, just about where I was expecting to see it fall. 4 meg. Again, same deal there. Okay, let's go ahead and go to 10. And we're getting 9.964. That's just about right. Right on, I should say. And here's 11. Should be a little bit under. And it is 10.967. Looks good on resistance. Very good on resistance. No problems there. Okay, here we go with the capacitance test. As you can see, I've already got this patched up, and we are getting a reading of 94 picofarads on 100, so pretty close, slightly low. 150 again. That's a little bit low, but pretty close. 220, that's a little low. 330. Taking it a while to get there, but yeah, that's a little bit low. 470, that's about right on. 560, that's just about right, slightly low. 680, that's just about right on. 820 picofarads, slightly low. 1 nanofarad, yep, just about right. 1.5, just about right. It's more like 1.4, 1.38, something like that. 2.2, that's just about right. 3.3, low as expected. All right, let's switch over to the high side of the box. 4.7, just about right. 0.56, low as expected. 0.68, low as expected. 8.2, that's right on the money. In fact, most of these have been right on the money on this side. 10, that's, yep, pretty good. 15 nanofarads, again, high as expected, but good. 22, look at that, bullseye. Okay, 33, high as expected. 47, this should be more like 49, and it is. 56 should be a little bit low, and it is. Notice a few of these smaller caps on this particular meter, it takes it a while to find them, but whatever. Okay, 68, that's right on there. That should be around 64, and it is. And then this should be 100 picofarad or 100 nanofarads. This should be around 102, 103, and that's, yeah, right on there on 103. So good there. All right. I would say this is usable pretty much down to about, I would say about, I'd say at least 470 picofarads. Let's bring in some bigger capacitors and see what we get. Let's try doing this 22 puff and see if it'll read that. Nope. All right, so I'll call the lower on this probably about 220 picofarads. 200 picofarads, I guess. Usable, more like probably more like about 500 picofarads. Okay, let's try the 85 nanofarad. Yep, taking it a while to figure that one out, but in the end, it's pretty much correct. Let's make sure it doesn't keep going up there. Yeah, we're good there. All right, here's 1 microfarad. If I could keep my hands on the leads, that was my, or yeah. Yeah, that's just about right. Let's try 10 microfarads. A little bit slow on capacitance. Okay, yep, that's just about right. All right, let's try the 47 microfarad. It should be more like 44-ish. Oh yeah, that's good. Okay, here's the 100 microfarad. Getting slow as we go up, and this is the case with most multimeters. Yeah, that's right on. All right, let's try 1,000. Yep, that's just about right for the 1,000 microfarads. All right, let's try the new and improved 2.2 millifarad. I fixed this. It had a loose joint on it, so we'll see if it behaves better. Of course, it also is dependent on me getting the probes on right. Looks like we got it. And that is just about right on. Yeah, I usually get about 2120, 2110. Yeah, perfect. All right, let's try the big one. See what this one does. It's thinking about it. Yep, that's just about right. So yep, overall pretty good on capacitance. A bit slow, but otherwise I think we're good. Okay. Well, let's go ahead and check on the output voltage. You know what? Since I got it out, we'll let the 1152T do the honors today. We're going to get these together. Sorry, I bumped the camera there. All right. Get this one turned this way so we can actually read it. All right, let's turn it on. Okay. So on the output, which we actually need to put it in that mode to get that to work correctly. There we go. Diodes. Let's see what we get here. A very healthy 3.283 volts. So, yep. A shame it won't read the drop voltages on the green, blue, and white, but lights them all up. If you need to test LEDs, you won't have any problems with this if you just need to illuminate them before you solder them down. Okay, here we go with the ACV Outlet Test. Got my outlet over here on, so let's go ahead and jam them in and see what we get. Getting 123.31 volts, and looks like a frequency of 59.9798. Okay, let's go ahead and take a look at the duty cycle. 50.2, looks good there. Okay, next up we're going to do the NCV test. So let's get these probes out of here. It seems to be kind of sensitive. I guess we're going to find out. I don't know if it's like squawking at me or yeah. Alright, well, let's give it a shot. Let's see what happens. I'll hit the backlight for this. Oh yeah, I'd say that's good. Let's try the LED light up above. Yeah, I'd say we're pretty good there. Alright, looks good on the EC, the NCV. Shut up already. Alright, next up we're going to do the thermoprobes. So let's get the thermoprobes out. These are the ones, of course, that came with it. And I'll put those in there real quick. Okay. Let's get it in that mode. Okay, 31C. Nope. Okay, it does go into Fahrenheit, so it does work with centigrade and Fahrenheit. It's kind of high. It's not cooling down any. Yeah, it's 74.3 degrees in here. It should definitely be cooler than that. I'm not going to wait for it. Okay. I guess it would eventually drop, but it's probably because I was jimming around with it. It is dropping. Let's go ahead and give it the body heat test. Yeah, it's reading that kind of high too. A little bit generous. Alright. Alright, let's do the fire test then. Let's see how fast we can make this jump. Oh yeah. Works just fine there. It seems to me that this does have a tendency to measure slightly high, but oh well. Okay, here we go with the frequency test for the Thsinde 18Z3. Now, according to the manual, this particular multimeter has a range of 10 Hertz all the way up to 20 megahertz. So I've got my tone generator set up with an amplitude of 2.5 volts, and we're running a sine wave to see how high we can really go. Okay, so here we go. We're going to start off with 1 Hertz. And it is picking up 1 Hertz, and the duty cycle is, a little bit, that's actually not bad. Okay, so we'll check that periodically as we go up. Let's go up to 10 Hertz here. Okay, 9.99 Hertz, looks good there. All right, let's go up to 100. 99.99 Hertz, looks good there. Duty cycle's good. All right, let's keep going. 1K. Looks good there. Okay, we'll go to, let's go up to 10K. Looking good there. 9.999K. All right, let's go to 100. 99.99K, looks good there. All right, let's go up to 1 meg. And again, 99.9999 megahertz. All right, and duty cycle's dropping a little bit, but still in fairly good shape. Okay, let's go ahead and go to, well, I'm going to go ahead and just push it up to 10. Let's see what we get. 9.999 megahertz, looks good. All right, let's go to 20. This will take us to spec. And we are getting over limit. Kind of what I expected. I was hoping we'd go above since it was auto ranging, but again, based on 2, so what we can do here is just drop it down a little bit until we get the reading again. There we go. That's at 19.997 megahertz, and its reading as 19.999, and this is this meter's maximum limit. But within spec on the high end, performed out of spec on the low end, so not too bad. Okay, this is going to be a quick and dirty comparison between the Thsinde 18Z3 and the UNI-T UT39E+, since these are both low-cost 20,000 count multimeters. Basically, the main difference between these two is that this one, the UNI-T, is a manually operated multimeter, while this one has also auto ranging. There are a couple of differences in measurements, but for the most part, these are the same class, roughly the same price, and everything else. So I'm going to do a quick comparison of who is better than who here, with their common functions anyway. So first off, when it comes to DC voltage and AC voltage, I would say it's pretty much neck and neck. It's a tie. The one advantage that the Thsinde does offer with AC voltage is you do get the secondary display showing the hertz, whereas this one you would actually have to switch over to hertz in order to read it. This one also will show you duty cycle, while this one won't. But the accuracy, and that's what we're talking about here, the accuracy is virtually the same. Okay, when it comes to AC and DC current, clearly I think the UNI-T is the better of the two. It's not a huge difference, but if you need more accuracy and current, this might be the way to go. Okay? When it comes to resistance and caps, I would say probably the Thsinde is a little bit better in both. Especially in the sense of capacitance. If capacitance is more important reading to you and you need accuracy, I would go with this one. Okay, diodes and LEDs, pretty much neck and neck. They pretty much work the same, and they're both do well there. Just don't expect to get drop voltage off of either one of these meters other than yellow or red LEDs. Okay. And the frequency, pretty much the same. We just showed that in the section prior. Both of these have an upper range of 19.999 megahertz, and that's it. That's all you get. But they do both work within spec, so I would call that a tie. Last but not least, non-contact voltage. Well, clearly the Thsinde is better. The NCV antenna in this one was very underwhelming and not that great. So if non-contact voltage is your thing and having a not very sensitive NCV is a deal breaker for you, then definitely go with this one. But all in all, it's really hard to go wrong with either one of these meters. They're both very good. They both have good resolutions. They're both built well, and I've had no problems with either one of these. Okay, and now on to the pros and the cons of the Thsinde 18Z3. First, the pros. It has very good accuracy on pretty much all measurements, the one lone exception being the thermoprobes, and even those weren't all that bad. The rail feature can pretty much be used on anything and everything, which if that's important to you, you'll be happy to know that it does that. Seems to be pretty solidly built. I would say like the 1152T. I compared it to the Fluke 17B in that video as far as build quality goes, and this one's just as well built. No problems there. Also a very good stand, very solid stand. Came with fairly robust fuses, especially on the 10 amp side where you got the, look what appeared to be an HRC fuse. A pity that they're only rated for 250 volts, but still, they look like pretty decent fuses. Okay, dual displays, and they both have 20,000 counts. Well, for under $40, you can't really shake a stick at that. It's easy to use, and the manual is well written and actually in a font that you don't have to squint to read, which is nice. Has lots and lots of accessories. As you can see here, all of this stuff that you see around this multimeter, save these batteries here, those actually belong to another multimeter, but everything you see in this picture here comes with this. 3 sets of leads, you get 2 regular sets of leads, a pair of pinchers, 5 alligator cables, a pair of alligator adapters, thermoprobe, battery, case. Did I forget anything? I might have. You get a lot of stuff with this, and that's awesome. Also, this meter pretty much would fit in any case made for a Fluke 17B or 117, something like that. And I know this for a fact because I have a case for my Fluke 17B, and this fits in it just fine. So if you want a more robust case, that certainly would be a choice. All right, on to the cons. First and foremost, my biggest complaint about this far and away is this stupid backlight. It makes this meter look really sharp and very viewable, but the fact that it only stays on for 15 seconds, bummer. I don't like it. I wish it'd stay on at least a little bit longer. As you can see there, yeah, it went off pretty quickly. Don't like that. Only one PTC and maybe a few MELF resistors for protection. Definitely not a category 4. This, once again, is just your regular, everyday, Chinese-made category 2 250 volt multimeter. But for an electronics bench, that's pretty much all you're going to need anyway. It is slow on capacitors, especially certain capacitor values. As when we were doing those tests on the substitution box, I noticed that this thing sometimes takes a while to get to the readings. Now the readings are accurate, and it's anywhere close as retarded as the O1 capacitance mode was, but it is, it does tend to get slow, especially on higher values, and that's pretty common with these class of multimeters. And last but not least, the thermoprobe measures somewhat high. To me personally, I couldn't care less about it, but that might mean something to somebody. And it was definitely going high on the body heat test and the ambient temperature test in this video, so yeah, I have to take off a couple points for that. Okay, so that brings me to the conclusion, and The Thsinde Z3 sports a complete set of features and dual display with a 20,000 count resolution and has very good accuracy across the board, pretty much. This meter would definitely be a great budget choice for an electronics bench that has the need for more precision than the standard run-of-the-mill low-cost 6,000 to 10,000 count multimeters that are out there. It can also play the role of a household DMM, although I would say that's probably a bit of overkill just for doing basic measurements around the house. But hey, if you want one, then you want one, right? Like its 1152T sibling, the Thsinde 18Z3 is a very surprisingly accurate and useful all-purpose meter. And if you don't want to spend around $39, you can always get the 1152T for around $22, $23. It's a very good meter as well. I definitely recommend this, and I definitely give this two thumbs up. I like this meter a lot. You're probably going to see this one appear on the channel from time to time, as I do with the meters that I tend to like. And that's going to do it. So thanks for watching the Thsinde 18Z3 video. Until the next time, we'll catch you later. This is Sui778. Good night.